Hello everyone, welcome to Algebra 1B. This is a video lesson for week 12, our statistics week. Let's get in and see what we got going on. So for week 12, this is the last week for Algebra 1B. As soon as you finish up everything, you are completely done and you will get your second algebra credit, as well as second half of your algebra credit. But you'll be all done with your first year of algebra. You'll be ready to roll right on into geometry. So let's get everything done. We're going to talk a little bit more about finishing at the end of this video. But for week 12, what are we going to be working on? Well, it's all about data and statistics. If I give you a set of data, we're going to talk about how to find measures of central tendency. That's mean, median, and mode. If I give you a set of data, we're also going to find measures of spread. That's how far apart the data is, range and standard deviation. We're going to look at, if we get a set of data, how we can use histograms and box plots to represent what is going on in the data, look for trends and patterns in the graphs. Finally, we're going to take some time to say, if we're doing a research experiment or if we have some question that we're trying to answer, how can we collect data that is unbiased and random and that can be used to help us understand the problem that we have? So data, data, data. So since we just did probability, I liked this chart. We're actually going to come back to it later on. But statistics is where math meets real life, where we actually try and use math analysis to help us understand what is going on. So we did a whole bunch of probability, right? In probability, we would use experiments. We would do a ton of experiments, gather a ton of results. And then what those would do is predict the probability that the next experiment, what would it show? So for example, given the information in the pail, we have a ton of information. What can we confirm about what is in our hand? Statistics is in the other point of view, or it's in the other direction. There's this giant pool of things and patterns and relationships that we don't understand. Statistics, we can pull small samples, we try and get little snapshots of what is happening, and we use little snapshots of what is happening to understand the overall general trends that we see in the entire population. So statistics is about, given the information in our hand in this small survey or small sample, what can we conclude about everything in the entire pail? All right. The other thing I want to get in, I just read a recent article in Wired magazine. I can forward this to you if you want it to. But this is how big data and statistics is, right? Everybody knows Google. Well, I just read this article about how Google is using all of its map, all of its satellite, all of its Google Street data, where they take pictures of literally the whole Earth all the time. They use all this data and they can take pictures and they can get pictures well enough to be able to look at what types of cars are in certain geographical areas. And they're able to take all this image data and they're able to look at the types of cars people drive, and they're able to predict pretty darn accurately the voting patterns of those people. For example, if you are driving a Toyota Prius, there's probably a certain type of person that will own and drive a Toyota Prius as opposed to someone who is driving a 1995 Dodge Ram pickup. You kind of already had those conclusions, but certain people, certain lifestyles, certain things lead you to buying a certain car as opposed to another. If you are a large family, you have a large car. If you're a single person, you'll have a different type of car. But anyways, they can take all of this data and they were actually able to predict which geographical area, what they voted for in the last election. And they kind of pulled that out and said, we can do a lot of other stuff too. They took parking lot data at the malls. And they were able to predict, well, based on the size of cars or how many cars are in the parking lot or not in the parking lot, they can indicate, well, what's the overall health of that company. For example, they took JCPenney and they noticed there was a trend of less and less cars at JCPenney's. And the results came out that JCPenney's had just declined by 10%. So the hope is, as Google is getting more and more data, more and more information, and they're using all this statistics and data, that they can change the way we understand our demographics. Rather than having to do door-to-door polling, they can analyze demographic changes. They can analyze economic changes all in real time and saving thousands and thousands, if not millions of dollars in costs to do big surveys and to gather population data. So this is where things are headed. It's all about big data, statistics, being able to use computers and artificial intelligence to crunch through all this data, big data centers, and begin to make decisions in terms of a global scale for what population. Anyways, I just thought it was a really interesting article. Keep your eyes open. You'll see more and more stuff like this about how companies are using data. So here's what we're going to be learning about. First of all, if you have a set of data, think of it like it as a big blob, right? One thing you want to know is, well, where is the middle? That's called measures of central tendencies. We're going to talk about mean, median, and mode. Then we're going to talk about the middle is great, but how spread out is our data? That uses things like the range and standard deviation. Once we have those two, or those central tendency and spread, we're going to talk a little bit about how to make graphs that analyze or give you a picture of what is happening with our data and how to interpret and create those graphs. And finally, a little bit about data sampling. Now, what's a little bit different is I want to go over these ideas rather than showing you math. We're actually going to pull up a data set. I'm going to show you how to use Google Sheets to do some of these different things and to do some statistics, because that's mostly what you're doing. You use computers to help you analyze large amounts of data. So we're going to do all this. We're going to talk about central tendency, spread, and graphs, all from Google Sheets. And then we'll come back into our PowerPoint and do a little bit with data sampling. Okay, so when we talk about measures of central tendency, we're talking about the mean, the median, the mode. You may have already know these, but the mean, we can also call it the average, but the mean value of a data set is you add up all the data values. So if you have 50 sets or 50 values in your data set, you add up all 50 numbers, and you divide by how many number of data you have. So I would add up all 50 values, and then I would divide by 50 to find out what the average is. The median is the very middle number. So if you were to line up all 50 values from smallest to largest, the middle value would be right in the middle. It would be between 25 and 26. That would be our median. The mode is the number that shows up most often. If you have a large data set, a lot of the times you like to find the mode, and then we compare all three of these to kind of see what is going on. If they're all the same, or if they're all different, each of those tells us something about what is going on with our data set. All right, so let's pull up a set of data and let's talk about how to find the mean, median, and mode. All right, here we are in our data set. This is what I shared with you. If you, again, for week 12 in our class, for the online activity, you need to come to this website, Dr. John Rasp's statistic website. You need to find an interesting data set that you want to use. I'm going to use NFL data from, I'm going to do the 2001 to 2008 seasons. So I'm going to click on this. These are all Excel files. So you can go click on it, download it to your computer. And then what I want each of you to do is we're going to go into your Google Drive. So use your Google Drive. You have a new button on the left, and you have the ability to create a new Google Sheet. When you do that, it should open up into a new spreadsheet just like this. So week 12 spreadsheet. You should call it with your name so you know what it is. But you're going to be using this. So hopefully you'll follow along and do this. But we need to get some data in here. Now spreadsheets are nice because each cell can hold a different data value. And then we have all these functions or programs built in to help us work with all the data in each row and in each column. So I'm going to take the data I did. We need to go up to File, and I need to import the data set we just downloaded. I'm going to import. I'm going to upload, select a file from my computer, and we download it in my download section. I'll look for NFL. And there it is right there. It's going to be uploading for a little bit. Hopefully it shouldn't take too long. I'm going to replace the current spreadsheet with the data I'm bringing in. It's fine because it's blank. I'll let it do its thing. And here we are. So what have we got? Well, we can see we have a column of years. So it's titling, this is the year. This is the week. So this would be a week 1 in the year 2001 season. Jacksonville was the home team. They were playing Pittsburgh, the visiting team. Jacksonville scored 21 points and Pittsburgh scored 3 points. So Jacksonville won that game. But what we have are data from all the NFL games from 2001, 2002, 2003, 4, 5, 6, 7, 8. A lot of games, right? 2,041 games of all the information from all 16 weeks of games. So this would be a lot to try and crunch out by hand, but we're going to use our spreadsheet to help us do certain things. So measure, we're trying to find central tendency, right? What is the middle of our data set? So first of all, let's calculate the mean. That's where we add up all the numbers and divide, right? So if I want to calculate the mean, I'm going to type in equals. As soon as I type in equals, this is a function. And we have mean is not built in, but we have average. In this case, the average value in a data set is the same thing as the mean. So now what's it doing? We're going to calculate the average, but now it's asking me, what do you want to calculate the average of? Here's where we go over and you highlight which cells you want to find the average. Let's find the average of the visiting score. So for all the visitors, what did they score on average for all 8 seasons, for all the games? Now I could click and drag and drop and highlight boxes, but since this is 2,000, it would take so long, I'm going to click entire column F. I want to know the average of all the numbers that are in F. It'll ignore the visiting score, it'll ignore spaces, it'll ignore words, it just finds the average of all the numbers. You can see there, the average of column F. I close my parentheses and hit enter, and there we go. So on average, the visiting team scores 19.89 points. Now, because I like to do some stuff, I like to analyze data, let's compare that with the home team. What is their average score? So I'm going to click equal, average, and now for the home team, let's call them D. And look at that, the home team scores a little over 22 points, the visiting team scores just under 20 points, which would make sense, right? There's a home court advantage. Home court teams tend to win more often than the visiting team because they're playing at their hometown. They don't have to travel. It's their own stadium. And so we see that the home team tends to score more than the visiting team. And our statistics prove that. But that's the mean. Let's calculate the median. That's another way to find the middle. So we're going to find the median of the visiting team. This time I click equals. And there's a median function. Start typing median, it pulls up the median value in a numeric data set. Still going to do column D. And so the very middle number, even though the average was 19.8, the very middle number of all these numbers is 21. Let's find the median for the home team. Whoops, that was the median of the home team. I didn't want to click D here. Hold on. This should be column F. So I can change something if I accidentally make a typo. There's the median of the visiting team. And now let's add the median of the home team. That would be D. So you can see even the median seems to support that the home team tends to score more than the visiting team. But it's not as much of a gap, right? 20 to 21 is different than 19.9 to 22.4. Finally, let's do the mode. The mode is the number that you see most often, right? Well, we have the mode as one of our functions. So we can click the mode of the visiting team. Wow, you see 17 is the score most often. Interesting. Let's find the mode of the home team. Column D. And you see the home team most often scores 20 points. That was the one that happened most often. So there you go. There's our central tendency. And we were able to calculate it and understand what is this telling us, and that they're all reasonably close, but they all kind of tell something different. In general, I would say the home team seems to score more than the visiting team just by looking at the central tendency. All right, back at that. So we know how to find the middle of a data set. We know how to use our Google Sheets to help us calculate the very middle, understand what it's telling us in the context of NFL scores. Let's talk about measures of spread. Well, spread tells you how far apart your data is. It tells you not only where the middle is, but is our data, are all the numbers really close to the middle? Are all the numbers far away? Are they really far away? And they give us a sense of what is going on. So the two we're going to focus on is the range. The range is simply the maximum value minus the minimum value. It tells you how far apart they are. But then we also have standard deviation, which is if the mean is the middle, what it does is take the average of how far away the numbers are from the mean. So deviation just says how far away is this one value from the mean. So it could be like 5 above, it could be 2 below, whatever. The standard deviation takes the average of all the deviations. So it gives you a picture of how far away they are. They're really good for comparing. There's really a lot we do with standard deviation as you get into more advanced statistics as well. So let's go open up our data set and let's go see how to calculate the range and standard deviation based on our NFL scores. All right, here we are. We've already got our central tendency. Let's find our measures of spread. Now, measures of spread, let's start with the range. So the range is the maximum minus the minimum. So there's no range function in here, but we do have the maximum and the minimum value. So let's go. We're going to do equals, and we're going to do max. Or look at that. If I type max, it pulls up the maximum. We're going to take the maximum value, and for the visiting team, so column F. But we're going to take that, and we're going to do minus the minimum value. Min gives you the minimum of F as well. So there you go. This is equal to the max score minus the min score. If I hit enter, it's telling me the range is 56. That must mean that the highest score and the lowest score is 56. Now probably there was a visiting team that scored 0 points in here, so the max score is probably 56. But there you go, we found the range. We have found out how far apart those are for the visiting team. Let's do that for the home team now. So equals the maximum of the home team, equals the maximum value of column D minus the minimum value of column D. And look at that, the home team, there's a bigger range, but they're pretty close, right? Let's now do standard deviation. So the average of all the deviations. So what I mean by a deviation is, here's the mean for the visiting team, right? The mean is 19.8. Pittsburgh, the very first game, had a score of 3. So the deviation would be 3 minus the mean, 19.89. So the deviation for Pittsburgh would be negative 16.89. Now Indianapolis, the next game, had a deviation of the mean it would be 45 minus 19.89. So it had a positive deviation. But for each one of these games, they're either above or below the mean, right? So if we found all these deviations, and essentially there's a formula that we use to find the average of the deviations, that gives us the standard deviation. It tells us how far above or below the means in general our numbers are. All right, so let's delete that. So let's calculate the standard deviation. So my formula, it's equal to, I'm going to start typing in ST, and there it is. STDEV is my standard deviation. So I click on that. Where do I want to calculate the standard deviation of? Well, for the visiting team, that's column F. And there we go. So the average or the mean is 19.89. The standard deviation is 10.2. So on average, teams seem to score above or below the mean by 10.2 points. So anywhere from 9.89 would be below to up adding 10 would be, about 30 points below. That's in general. The standard deviation helps you see some of that. Let's compare it to the standard deviation of the home team. So STEV of D, the home team. And look at that, they're almost exactly the same. The home team has a slightly bigger standard deviation, which seems to kind of make sense because they also had a slightly bigger range. So there seems to be a little bit wider of a dispersion in terms of the scores the home teams do. So they tend to have the potential probably to score a little bit more, but they also have the potential not to too. So a little bit wider of range of data as compared to the visiting team. But they're reasonably close. But that's what the measures of spread gives you, the standard deviation. If the standard deviation of a set of data is a lot larger compared to another set of data, it means it's spread out more, it's farther apart. Okay, so we've calculated measures of spread. Now let's start getting some images. Let's start looking at some pictures of data. Again, if you have 2,000, 4,000 numbers, it's hard to see what is happening. And so we have statistics to help us look for patterns, to help us analyze what is going on and actually see beyond all the vast scope of numbers. So let's go back and let's talk about box plots. So a box plot is simply a graph that uses the following numbers to organize the data into quartiles. So with a box plot, we find the minimum value, we find the maximum value, we find the median, that's the middle, but then we also find the quartiles, quartile 1 and quartile 3. You can think of these as quartile 1 is like the median of the bottom half, it's the middle number of the bottom, and the quartile 3 is the median of the top half. And what it does is you get 4 sections where you can kind of see which numbers were in the top half, which numbers were in the bottom half. How many data values are in the top 25%? How many in the bottom 25%? You can see if there's a spread or if they're tightly close together. So let's do these, and then let's go make our own box and whisker plot and analyze what's going on. Okay, so here I'm on my spreadsheet. To get a box and whisker plot, I need to add on a special statistics package. So I'm going to click on add-ons. I already have it installed. It says statistics right here. But if I don't have that, I want to click on Get Add-ons. And I want to do a search for statistics. And I want to install this package right here. So I want to manage statistics. All right, so let's close that out. Well, if I don't have it installed, make sure you click plus and add it. But anyways, get it all installed. So when you do have it, you can click add-ons. Once it's there, we're going to click on describe data, and it's going to open up some cool options for us to do. So it's loading my sheet. Here it's looking at all the numbers in the entire sheet. And there's some things we can do with this. So first of all, I don't want to have it select or do anything with these. So I'm going to adjust my sheet to go from A1. So that's A1, this first column. But I only want it to go down to F to the very bottom of F. I'm not worried about column G, H, I, or J. Notice this is going all the way to J. So I'm going to change J to just pull from F. And it's going to ignore all the other calculations I've already done. Because these, if I use these, they'll throw up my data set and add numbers that I don't really want. All right, so there we go. We're going to use those. Click OK. You may need to adjust this for your set, may not. Oh, there we go. I had to select the sheet, select the range, go from F. Now we're OK. All right. Now what do? We want to make a box plot, right? So I'm going to pick, I first need to figure out what I want to do a box plot of. Well, we've been doing visiting team and home team, so let's start with the visiting team. So I'm going to select variable. I'm going to select visiting score. I want to make a box plot of all the scores the visiting team did. All right. And let's do both of them. Let's also do home score. So there I've got both variables. I want to make a box plot of both the visiting score and the home score. You can ignore the functions. We're going to leave it at none. That's kind of more advanced for what we're going to do. But now you got some options here. We can make a histogram, a density plot, a normal QQ plot. We're just going to focus on box plot and create a box plot of these two variables, the home score and the visiting score. So create it, let it process, let it do its thing. And when it's done, there we go. We've now got our scores up here. So I'm going to close this out to help make it easier to see. And what do we got going on? So we got our visiting score. Here's our distribution. We can see the minimum value. There's the quartile right around 12. There's the median right around 20. There's the upper quartile, quartile 3. There's the maximum, and then there's all these points out here. Box plots, they're actually telling me that all these values are kind of outliers. These were really high scores in games that for all intents and purposes aren't really realistic. And there's mathematical methods for determining if it's an outlier or not programmed into this. But just assume that, yeah, 56, 49, 49, these are scores that are really high and not really considered normal to our data set. Notice it's also giving you the mean. It's also calculating the standard deviation. It's telling us how many data values. So it's taking 2,040 scores for the visiting team. It also gives us some stuff about percentiles, right? So we can see that for scoring 3, the 5th percentile is 3 or more. If you want to find the mean, the 50th percentile, half of the scores are below 20. 90% means that 90% of all these values, all 2,040 values, are 34 points or below 34 points. That's the 90th percentile. So think of it just in terms of scores and how common or not common these scores are. So 95% of all the scores are below 38 or right at 38 points or below. 99% of all the scores are 45 points or below. And so you can see why these are outliers if they're 49 or 50 or 56. They just rarely happen. Here's some other stuff in here. These are the outliers. Here's your quartile. So there's your minimum. There's your quartile 1 is 13. There's your median is 20. There's your quartile 3 at 27. And there's the max that we're using at 48. So this is how they're creating the box plot. And we can use those values and say, well, 25% of the numbers are between 0 and 13. 25% of the scores were between 13 and 20, and so on and so forth. And we also have both of them on here. And so we can easily compare if I wanted to. We could compare box plots and say, let's line up both the home score and the visiting score, and let's see if there's any difference in the images. Now, when I'm looking at it, the home team, this box seems to be just slightly to the right. The median is higher, this third quartile is higher, this first quartile is higher. So you would say from the box plot, the tendency is that most of the scores, the middle 50% of the scores, tend to be a little higher than the middle 50% of the visiting team scores. So you can say, yeah, the home team tends to score a little bit more. We can see that in the box plot. The max is still roughly the same. The minimum is still roughly the same. But if you just take the middle 50%, you can kind of see the trend is a little higher scores for the home team. Now, on your assignment, when you're working on this project, I want you to, at one point, you're going to copy the histogram. So if you right click, well, you can't right click, but if you click on it and it's highlighted in a box, you can edit, you can copy it, and then you can paste this picture into Google Docs saying, yes, I can make a box and whisker plot. Here's the box and whisker plot for my data. So that's one thing I want you to do for your data, create a box and whisker plot, and I copy it and paste it into the Google Doc for your project. All right, but there we go. That's a box plot, right? It gives us a picture, a really fast picture to see what is going on with our data. All right, besides box plots, we also have histograms. A histogram, it's another way to look at your data. It's sort of like a bar graph, but it's not. But histogram uses what we call bins and bin widths to determine how many data values fall into each bin. I want to do a quick example for that. So say you have the numbers 1, 3, 4, 5, 8, 9, 9, and 10. These are my data values. We got 1, 2, 3, 4, 5, 6, 7, 8 data values. And say I make a bin. We have one bin going from 0 to 3. We have another bin going from 3 to 6. Another bin going from 6 to 9. And another bin going from 9 to 12. What I then do is sort each of these numbers into the right bin, and I keep track of how many of our data values are in that bin. So let's look for 0 to 3. So 1 would be between 0 to 3, but that's the only one. 3 would seem like it goes there, but if it's 3 is right on the border, it actually gets counted in the next one. So if I'm making a histogram, we have exactly one value in the data set that is in this bin. Starts at 0 and goes up to 3. All right, now how many go into 3 to 6? Well, there's one number, 2 numbers, 3 numbers, and that's it. 8 is too big. So it looks like there's a frequency of 3. There's 3 numbers that start at 3 and go up to 6. So 1, 2, 3. So I would make a bar, taller bar, and say, yep, there's a frequency of 3. All right, 6 to 9, how many are in that range? Or how many in that bin? So 6, 7, 8. 8 would work in there. But not 9. 9 goes in the next one. So now I have to say, well, there's only one data value in this bin. And finally, 9, 9, and 10. 9, 9, and 10. So there'd be 3 in this bin. That's roughly the process that you do to make a histogram. Now, if you have thousands of data sets, it does all this sorting for you. And usually any histogram, you can set the bin width. So we made a bin width of 3. Maybe I want to go 2. Maybe it goes 0 to 2, 2 to 4, 4 to 6, and maybe that would make it. There'd be more bars, but it may be helpful. Maybe I'd want to go every 4. Maybe I want wider bins. So we can make wider bins or narrower bins depending on what seems to help us understand the data. But it gives us a picture of what's going on. We had a lot of low numbers between 3 and 6, a lot of 9 numbers between 9 and 12, but we may say, well, why is there only 1 in this set? They tell us a picture, they give us an idea about the shape of our data. All right, let's go into our data set with Google Sheets, and let's look at how to make and interpret a histogram in there. All right, here we are. We're in our NFL data. There's the box plots I already made, but we want to make some histograms. We want to see what's going on there. So I got my data set. I need to go open up my add-ons, my statistics describe data. It's pulling from my sheet. Again, I don't want this data over here, so I'm going to select. I still want this sheet of NFL data, but I only want to go through column F. So I'm going to make it go from F all the way down to row 2041. So there we go. Click OK. Let it process. I want to pick my variables. So I want to make a histogram for the home score and a histogram for the visiting score. So I'm going to pick home score and click OK. And then pick visiting score and OK. So there's my 2 variables. And we're going to check histogram, but not any of the other ones. So we're just going to make a histogram. All right, let's let it do its thing. There you go. Now we've got a new tab down below, and we have some histograms. Now it's setting all the frequency stuff. I'm going to close this out. It's setting the bin width for us based on our data set. And I don't know if it's adjustable. You probably can get it and adjust it. But for right now, it's pretty good. It's kind of using its own statistical methods for figuring out the appropriate bin width. So there we go. We have our scores. And if I look at what's going on, it looks like it's a bin width of 5. So we're going from 0 to 5. How many scores were in that range? And you can see, oh, there's actually 57. From 5 to 10, there were 235. Now you may be saying, well, what's that 7.5 up there? That 7.5 is telling us the very middle of the bin width. So between 5 and 10, the middle is 7.5. So it's telling us that's sort of the middle value of that bar. 2.5, 7.5, 12.5. You can see that it does make a bin width of 5. From 10 to 15, how many scores were from 10 up to 15? Well, there were 224. So you can see the most of all, for if you're a home team, you tended to score the most scores were in between 15 and 20 points. But it makes sense that in the middle, these are higher, and then the low scores tend to be lower, and the really high scores tend to be lower. So it kind of makes what we call a curve, a normal curve. Let's compare it to visiting scores. So you can see from 0, there were more scores that were lower, 123 as opposed to 57. There were twice as many scores for the visiting team that were between 0 and 5. But it kind of goes up a lot higher, so it goes up 500. Notice this one goes up to 400, where this one goes to 500. So it can kind of, when you look at it, skew already what's going on. Let's see. We can right-click. I can also go to Advanced Edit, and let's see if there's a way to change this axis up to 500 to match the other one. And there we go. Minimum, I'm going to go from 0, and I want to go up to 500. All right, but at least it fits a little bit better. So now this one goes from 0 to 500, and this one goes from 0 to 500. If I just tweaked a little bit, so I didn't make a match, but you kind of want to, if you're comparing two things, we want our axes to match as much as possible. And the x-axis goes from 0 to 60, which is nice on both. But if I want to compare, I also want the vertical axis to compare and be the same, so that what I'm looking at visually actually makes sense more. There you go. We can compare the histogram. We can get a picture of, you can see that most times there's a certain amount of scores, and it goes up, but it kind of tails off a little bit. So you can see that although it's rare to score 35, 40, 45, or 50 points, it tends to happen, but it doesn't tail off the same way, mostly because you can't get a negative value. If you score 0, you just score 0. You can't get below than that. So it's like sort of ignoring this tailor part there. So we got our histogram. Again, I can click on it, and then I can copy that, edit, copy the histogram. I can paste it into a Google Doc if I want to show up same thing. Gives us the same mean standard deviation. It's giving us our percentiles. So we can see the 50th percentile, we can get the mean and the medians. And then for our histogram, here's our bin width, right? So 2.5, 7.5, 12.5. I could change these if I wanted to. So it gives me the middle one. It's telling us how many values occur in that bin. So what did we do? We're able to take any data set we want now. We're able to upload it into our Google Drive, create it with a Google Sheet where we can do a lot of statistical stuff with our data set. And that is actually a really good skill to have, is to be comfortable either using Google Sheets, or a similar program would be Microsoft Excel, or it's just spreadsheets, but it's a handy skill to be able to take sets of data for whatever company, whatever job you have, and be able to do some things with it, be able to use functions, be able to search for things, be able to do some statistics with all the numbers you have. So hopefully that's a good skill for you. All right, the last little thing I want to talk about is collecting data. Again, that chart, right? If probability is taking a whole bunch of experiments and then applying them to the next event, statistics says, okay, let's take some samples, take what we know, and apply it to what we don't know. What this means then is we need to make sure what we have in our hand is really, really good data. If we're going to try and generalize it to larger populations, if we're going to say, because of the results of this experiment, this is what is going on, we need to make sure that our experiments are valid, that we have really good numbers to work with. Otherwise, any results we make, any observations we make, any trends we see are not going to be valid because we have bad data to begin with. So we need to make sure, how do we get good data to do all this stuff with? Let's think about this question. You have a class assignment. You've been asked to find if students in your school are planning to attend university or college after graduating high school. Students can respond with yes or no or undecided. How will you choose which students to interview if you want your results to be reliable? This is kind of the conundrum, or this is the thing that people have to think about when you're trying to get data, when you're trying to answer some questions based on experiments. How do I get good information that is reliable that I could apply? So one way might be to say, well, let's call 10 students and just ask them. Well, we can ask them this question: are you attending college? We get yes, no, or undecided, but how do we know which 10 students to call? Is 10 students enough? How are we making it truly random? This is the idea that we want random. We don't want any bias. We don't want the way we're asking questions or who we're getting information from to be slanted in a certain sort of way. All right, so how do we call? We could call 10 students. We could email, email 1L. We could email 100 students. But then if you email, most students are probably, they're probably not going to respond. They may respond, but we do surveys all the time at Summit Learning where we send it out and we see how many people actually take the time to go in and fill it out. So you have survey response, and you have to ask, well, who is filling it out? Is it just people who are really mad? Or is it, in this case, people who are going to college are going to respond, but the people that aren't going to college are going to just not even bother doing it because they don't want to do it? So you have to think about all these sorts of questions when you're trying to figure out, how do I get data? How do I know in our school how many students are going to yes or no? Now, our school is not that big, so we could realistically make an effort to email, call, ask every single student, and that wouldn't be impossible. But what if we wanted to know every single student in Oregon? How many students are planning on going to college or not? Now that gets huge. That's a huge amount of students to figure out. So that's where you have to take a sample of the population. The population would be all the students in Oregon. We have to figure out, how do we get a small sample that represents the population, that's truly random, where we get asked this question, we get yes or no's, undecided, that actually represent the true population. So you have to think about like geography, you have to think about where you're asking, you have to think about how you're asking, you have to think about what format, all this stuff, and work through those things. Our textbook has a lot of information around thinking through situations and trying to get your data to be purely random and as unbiased as possible. So speaking about bias, here's a few examples of bias. So we're going to read through each of these, and I want you to think what bias is going on. Here's the first question. You're asking people shopping at a farmer's market if they think locally grown fruit and vegetables are healthier than supermarket fruits and vegetables. Is there any bias in this? Well, who are you asking? You're asking people shopping at a farmer's market. You have to keep that in mind, that the people shopping at a farmer's market are shopping there because they do think locally grown fruit and vegetables are healthier. They already have this presupposition. That's why they are here. So the results you get are probably going to be overwhelmingly yes. because they're choosing the market over the supermarket in general. And so it may not be the best result for what you're trying to answer. Probably you're trying to figure out the general population. So maybe it would be better to pick random numbers out of a phone book and call. Maybe it would be better to stand outside of by the post office and just interview every fifth person that comes in. There's other ways we could try and get more of a representative sample than just specifically asking people at the farmer's market. So yes, this one is biased. How about number 2? You want to find out public opinion on whether teachers get paid a sufficient salary by interviewing the teachers in your school. All right, think about this one. If you go to teachers in your school and you ask, do you feel like you get paid a sufficient salary? There's already a lot of bias because most everyone in any job always feels like they should be paid more. They always feel like they do more work and that they're underpaid. That's just kind of life. So if you're trying to find out public opinion on teachers, then you shouldn't ask the teachers about teacher pay. You need to figure out how to ask the public. Again, it's biased because you're not asking the right sample of who you're trying to get information from. How do you sample the public? Well, you could stand outside the supermarket. You could pull random numbers from a city in the phone book. You could try to hit geographic areas and go door to door. There's other ways to try and make this more random and not biased. But definitely there is some bias inherent if you just ask teachers and try and base public opinion on just the teachers. All right, last one. You want to find out if your school needs to improve its communications with parents. So you send home a survey written in English. Well, let's think about this one. This is actually probably common from schools, but they're more and more starting to think about it, is how well do you think it's going to improve if there's people that don't speak English? You're missing a whole segment of the population of students as more and more we're a diverse population. More and more we have Spanish-speaking students, Russian-speaking students. We have multiple language of students that'll come in here, Somali, just lots of them, right? Arabic. How do we actually get all of the students and get some idea? So if we send a survey written in English and the parents or the student doesn't speak English, they're not going to be able to give very good feedback. So all the responses you may get may say, oh, the survey is fine. There's great communication. But you're completely excluding a whole population because they can't even access the survey. The parents can't read or respond in English. So yes, this one does have a lot of bias because we're ignoring all the non-English speaking families and not getting that data into if we need to improve. And yeah, probably the school does need to improve its communications so that it actually is hospitable, that it is open communication with all families of all languages of the school. So yeah, these are 3 good examples of thinking through bias, thinking through getting data. How do we get data? Finally, if you want to design a survey, what do you want to keep in mind? Well, your textbook gives some good ideas, and so I just want to pop those out. When you design a survey, you want to have a goal in mind. There's a certain thing you want to measure, or there's a certain question you want to get at. Make sure you know what your survey is for. Once you have your survey, then think about, okay, if this is what I want to know, who do I want to know this about? What is the population I want to interview? Am I actually interviewing the right population based on what I want to know? So think very carefully about the information and who you want to get information from so that when you are questioning or giving out your survey, you're actually getting the information from the right people. Once you know your population, now you can think about how you want to administer the survey. Do you want to send something out by mail? Do you want to send something out by email? Do you want to put a flyer on the car windshields? Do you want to phone call? Do you want to do an online survey and send them the link? There's all sorts of different ways you can gather information, and there's strengths and weaknesses of all of them. But how do you want to administer the survey? Finally, as you start getting results, you need to have a data collection sheet. You can use an Excel sheet, a Google sheet, but you want to record the results. You want to know, be able to tally all the results so you can get a spreadsheet, so then you can start doing some wonderful statistics and graphs based on the data you get. That's kind of the process. Now it's fun. Hopefully as you go on and on in your school career, you'll actually have the chance to design a survey and get some data. But for our purpose for week 12, I already got some data samples for you because I want you to dig in and play around with some of the numbers. Okay, just to end things, for week 12, there is no quiz. I want you to put some more time and effort into the online project using the data set. Hopefully you already have one. And the methods that we went over in this class. I did make a video and I posted it showing you a little bit more in depth. So if you go to the week 12 project, you can see that video in there. There's a whole bunch of steps. Put some good work into it. I want to see some analyzing your data. I want to see mean, median, standard deviation, calculations, histograms, box plots. And once you have all that, I want you to see what in the data is important. Is there important information that you are seeing from your statistics, from your graphs, and that you can share with others? So on the project, I want you to write up and say, based on what I'm seeing, here are some patterns, some trends, important information that would be useful in some decision-making process based on the data. So there's a Google Doc. I'll show you where it is here in a second, but make sure you're opening it up, filling it all in, showing me your project, and displaying all your great skills and statistics skills with your data set. In case you need to see it, for week 12, on the week 12 online activity, this is where I want you to actually do the project. Notice there's no quiz, but you can see there's the link to the website. Again, there's dozens of data sets you can download and work. I've given you step-by-step instructions. There's a Google Sheet. I'm going to open this up for you. You're going to make a copy. And as you're doing all your Google Sheet work, your spreadsheet work, as you're getting all your data, I want you to put all your results into this Google Doc, the week 12 statistics project. Make sure you put your name on it. You're going to describe your data, how it was gathered. You're going to fill out this information on your data set, put in your box plot, put in your histogram, and then I want a paragraph or two about observations and trends and things you notice about your data set. Once you have this done, you're going to share it. You're going to get the link, and then you're going to paste the link into this activity to turn it in. Again, I made a video here, so Algebra 1 Week 12 online activity. This is a 15-minute video that'll go through all those steps for you. You can play it in one window and go step-by-step, pause it to help you navigate it. But this video will really help you walk through it. But if you're in class, we'll start doing some of this as well too. Finally, we're at the end of Algebra 1B. This is it. This is it, last week. So make sure you're completing all the assignment requirements for weeks 1 and 12. Let me know if there's anything you have a low score on, such as a paper pencil assignment or a quiz, whatever. Let me know if you want to work together on redoing anything. I would rather work with you, go over the questions, make sure you understand it, and give you a better grade. That would be my preference. Check all your grades in Canvas. Make sure that you're happy with your final grade or that there's nothing missing or no inconsistencies. If you need some time to finish this, if you are a few weeks behind and you just know you're not going to get it done, check in with me about taking an incomplete but getting more time to finish the course. And finally, fill out the end of class survey. So in the week 12 module, you'll see an end of class survey. Click on it. It's a Google form. Again, it's a survey. I made a survey. I'm collecting information from all of you guys from my own data statistics. I want you to fill it in. Let me know. Give me some feedback about how this class was. I'd appreciate that. And you'll be all done. Congratulations. It was my pleasure working with all of you. I hope this was a great algebra experience. And good luck with your next math class.